Good morning, students. Today we are going to see the subject electromagnetic fields. Our subject code is 22WC07 electromagnetic fields. So in these subjects we are going to see the introduction to electromagnetic fields, then unit 2 is electrostatics, then unit 3 is magnetostatics, then electromagnetic fields, then last unit is electromagnetic interference and compatibility, that is EMI and compatibility. So in unit 1, introduction to electromagnetic fields, we have sources and effects of electromagnetic fields. Next, introduction to vector algebra, and then coordinate systems. Vector calculus, we have to see gradient, divergence and curl. Then we have divergence theorem, Stokes theorem. Okay, so in general, electromagnetic is the study of effects of charges at rest and charges in motion. So generally, we have atom, we have electrons, protons and neutrons. So electron having negative charge, similarly proton having positive charge, and neutron has no charge. Okay, so electromagnetics is the study of the effects of charges at rest, that is in stationary part, and changes in motion. So, okay, so we have electrostatics, then magnetostatics, then electromagnetic. So we have three cases. So in electrostatics, here the charges at rest position, okay, there is charges in the stationary, there is no movement. Okay, so that charges, positive and negative charges at rest position. Okay, whereas in magnetostatics, charges in moving condition, that is steady motion. So steady motion means we have called it as a DC. So we have DC effect, direct current effect. Then another case, electromagnetic case. So here charges in time varying motion. So charges are moving with respect to time. That is similar to AC condition, that is alternating condition. So here charges are moving with respect to time. Is called electromagnetic. So here we have electrical effect as well as magnetic effect. Whereas in magnetostatics, charges in steady state condition, that is we have charges, constant charge with time axis, charges in steady motion. Okay, so generally we have vector and scalar quantity. So fundamental vector field quantities in electromagnetism. In general, we have electric field intensity. Is called E. So that unit is volts per meter. So E equal to, so here E equal to, okay, E equal to volts per meter. Then we have electric flux density, electric displacement, we call it as D. So that unit is coulombs per meter squared. Then whereas in magnetostatics we have magnetic field intensity H, that unit is ampere per meter. And then magnetic flux density is called B. So B is normally unit is Tesla. So Tesla equal to Weber by meter squared, that is magnetic flux density. So flux by area, flux in Weber divided by area in meter squared. So we have Weber by meter squared. Okay, similarly, suppose we have field. When an event in one place has an effect on something at a different location, we talk about the events as being connected by field. So in a transmitter and a receiver, suppose we have a transmitter, that signal is propagated through antennas. So here the transmitter, in the sending end we have transmitter, whereas in receiving end we have receiver, are connected by a field. So field is a spatial distribution of quantity. In general, it can be either scalar or in vector nature. So scalar is the quantity that is fully described by magnitude only. So for example, speed is a scalar quantity, whereas in vector we have both magnitude as well as direction. So weight is a vector quantity. So we have magnitude as well as direction. Okay, so we have two components, scalar and vector. So next we are going to define unit vector. So unit vector is a vector with the magnitude of one unit. So any vector can be expressed as a scalar multiple of its unit vector. So generally, so vector can be represented by OA. OA is my vector. Suppose OA, suppose OA is my vector equal to, so we have magnitude that is OA bar, then unit vector A cap. So from that, unit vector A cap equal to OA vector divided by magnitude. So the vector locations in a Cartesian system, whereas in Cartesian system we have x, y, z axis. So vector along x axis is called ax vector. Then similarly vector along y is ay vector. Similarly vector along z axis az vector. So that unit vectors having magnitude of one value, so it has only direction. So in general, a unit vector is defined as a vector OA equal to that vector OA divided by magnitude of that vector.